Moving along, we've now got balancing of atoms and balancing of charges. So, to get our complete equation, we need to do a fair few things. We always have to balance the charges and then look at the atoms to balance the whole equation. So, first, let's look at an example. So first we're going to look at the charges. We've got our magnesium, we've got our valency of 2 plus, or plus 2. Hydrogen, remember, is plus 1. Chlorine atom is minus 1, so that is neutral. Positive and negative equals 0. We've got our magnesium here, 2 positive, and 1 chlorine, 1 negative. And our hydrogen, which remember we always have to have as hydrogen gas, so it always has to be H2. So these electrons are actually being shared, so we don't actually have a charge on this. So don't worry too much about that, but you always, when you have your metal and your acid, you produce your salt and hydrogen gas. Remember our pop test? Our hydrogen gas was what we actually heard being burnt. So now looking onto balancing the charges and the atoms. So, good clear thing to look at. We've got 2 hydrogens here. We've got 1 hydrogen here. We've got a charge of plus 2 for the magnesium, but a charge of minus 1 for the chloride. So obviously we have to do some changes. So when we're balancing charges, and looking specifically now at the atoms, to balance these charges out, we have one of 2 ways. We can only do it one of these 2 ways. So first up, if we want to have this whole thing, so for each of these atoms to be increased, so we could put a 2, we could put a 3, we could put a 4, doesn't matter, depends on your equation. So imagine there's 2 little brackets out here, just imaginary little brackets. So we times them like multiplication. So there's 2 hydrogens and 2 chlorines. The other way that we can balance, also here, is if we're just looking at the one thing, we can actually put it below. We call this a subscript. So it's below the normal writing. So sub, below, script. So if we're looking back up here, there's a couple things we need to fix. Our magnesium, all good. We need to now look at, first we'll start with the charges. So we've got our magnesium and our chloride, 2 positive, 1 negative. So we need to add another negative. So to do that, we need to add another chloride. So our magnesium chloride is actually magnesium and 2 lots of chlorine. Remember, hydrogen always does the same. So we've got that. And remember, I also said that we've got our hydrogen here and our hydrogen. We've got 2 on the product side, but we've only got 1 on the reactant side. So anytime you want to balance charges and atoms, so to make your complete equation, you need to look at what's on your reactant side, what's on your product side. So let's go through it. Magnesium, magnesium, so 1H. Hydrogens now, we need to have 2. Because we have 2 on this side, we need 2 on this side. The chlorine as well, remember we just put the 2 there. So we need to now balance it out. Remember we can have our imaginary brackets. So this is actually what we use for this one. So we put the 2 outside, so we have now 2 hydrogens and 2 chlorine atoms. So, do we have a balanced equation? We have 1 lot of magnesium, 1 lot of magnesium, 2 hydrogens, 2 hydrogens, 2 chlorines, and 2 chlorines. Done. That is our balanced equation. Now, there's only one more thing we have to add, which is the challenge on your sheets, which is talking about the complete equation. So your complete equation takes into account what we call the states. So when we're looking at a solid, so remember what we did in our experiment. This is exactly our experiment. We had the magnesium in the tube, and we had hydrochloric acid that we added to it. So we put that through in a little dropper. We had magnesium chloride being produced, and we had the hydrogen gas. So what we actually do, we use these little symbols. So we have solid as S, gas as G, liquid as L, and AQ, which is an aqueous solution. So when there's strong acids, we can say that they're liquids. Otherwise, if it's been diluted, so it's in a water solution, so it's in an aqueous solution, aqua, water, we can put it as AQ. Our salt, also remember in this case, we still have it in water because our acid was quite weak to start off with. So we usually put it as AQ. And remember our hydrogen building up in the tube, we had it as a gas. So we have our solid, we have our aqueous solution for the acid because it was quite weak. If we had a much stronger one, it could have been a liquid. Our magnesium chloride, which is always in an aqueous solution. And we have our hydrogen gas. So now we can see we have our complete equation. Only a few more experiments to go and we are done.